Good evening, everyone. So, as you might be aware, that we'll be taking up some PYQs like previous questions over hyperbola. So, we had already covered like conics theory part and some PYQs over parabola. So, now let's get over to hyperbola. I'll give you a brief up because we have been studying the conics for quite some time now. So, if you remember what a hyperbola looks like, this is what a standard hyperbola looks like, and the conjugate hyperbolas look somewhat like this. And the equation that we have for the hyperbola is x square by a square minus y square by b square is equals to 1. This is my y, right? So don't mind it. So this is what a standard hyperbola looks like. So just to brief you up, now let's get straight into the questions and see what do we have here. The first question that we have here is the equation of the hyperbola whose foci are this and eccentricity is 2. Okay. So eccentricity is defined by root over 1 plus b square by uh, 1 plus b square by a square, that is equals to 2. So we get that b square by a square is equals to 3 and b square is equals to 3a square, right? This is what we get. And the equation of the hyperbola whose foci are this. So the distance between foci is 2ae, is it not? It is, right? Are we sure about the distance between foci of a hyperbola? Just give me a minute. I'll just check it through because I'm really sorry, guys. Yeah, it is 2a in the terms of hyperbola as well. So we know what the hyperbola, we have gotten the relationship between b square and 2a square. And now to get the relation between the distance and get one more equation. So we know 2ae is equals to root of 10 square. So that gives me 10. So 2a becomes 10 and ae becomes 5. We already know e is 2. So a become 5 by 2. No. So no. So b square becomes a square 3a square, right? So 5 by 2 whole square. So my b square becomes 25 into 3 is 75 by 4. So this is what we have. And my a square is 25 by 4. So now what we have to find the equation of the parabola, right? And okay. So first things first, we also have to see that yeah, sorry for the sneeze. And the center, we have to find the center, the origin for the hyperbola, right? So the new hyperbola is 6 plus minus 4 by 2, that is minus 1. And we have 4 plus 4 by 2, that is 4. So these are the two centers that we have. So it is plus 1, sorry guys, I don't know why I wrote minus 1. This is plus 1 and 4. So my equation becomes x minus 1 whole square by upon a square minus of y minus 4 whole square by b square is equals to 1. And we know what a square and b square is, right? Also, someone would say that why we have not considered the minus a square by minus x square by a square plus y square by b square. It is because of the same reason, because if you see foci, here the foci is y-axis is like the foci lie on this one of the lines that are parallel to the x-axis. So this hyperbola is somewhat of this type. If it would have been a case of the foci would have been lying on a line which had been vertical, then the conjugate hyperbola would have been considered. But since it was lying on a line that is parallel to the x-axis, we considered the original hyperbola or the normal hyperbola, what we say. So let me just erase this up and get back to the new question. So let us move to the question number two. The question number two says, touch the hyperbola at infinity. So for a standard hyperbola, when x minus y square is equals to a, we have the asymptotes as x is equals to plus minus y, right? So what we try to do here is we get the equations out, and we also know that the standard formula that we use here for the asymptotes is the equation of the hyperbola minus the equation of the asymptote is equals to a constant. That is like the standard thing, right? So the equation of the hyperbola, what we get is the equation of the hyperbola is equation of the asymptotes plus is equal to a constant or plus constant whatever. So we what we do, I'm not writing this for you guys. You can like read through the solution because it's a very direct formula based question that we have here. I'll zoom it for you guys. So what we have here is we have two asymptotes and we have to find the equation of the hyperbola. So the easier way to go through is using a direct formula. That is, equation of the hyperbola minus equation of the asymptotes is a constant. We are aware of this. We have derived this while studying. So when we use this equation, we also know that the hyperbola is passing through 1 comma 1, right? So we'll just simply put the values of x and y as 1 and minus 1 and get the value of k. So this is what a hyperbola indeed comes out to be. This. So quickly moving on to the next question because we have less time. Just give me a minute. So let's move on and to the next question. So if E and E dash are eccentricities of two hyperbola conjugate to each other, that is, we know. So very easy. So I'll just do this. It's a very easy question. So see, we know what a conjugate hyperbola is, right? So x square by a square minus y square by b square is equals to one is a normal hyperbola. Then the conjugate looks like nothing but minus x square by a square plus y square by b square by is equals to 1. So eccentricity in this case is root of 1 plus b square by a square, and eccentricity, let's label them as eccentricity 1 and eccentricity 2. So eccentricity 2 becomes 1 root over 1 plus a square by b square. It's as simple as that. And now what do we have to prove? We have to prove so squares of those, right? So e square becomes 1 plus b by a square, and e2 square becomes 1 plus a square by b square. And now taking a reciprocal of this means e1 square becomes, sorry, 1 by e1 square becomes a square upon a square plus b square, and 1 upon e2 square becomes b square upon a square plus b square. And taking the sum, we get a unity, right? That's a very simple derivation. So we are done with the third question as well. I'll just take the question to avoid any confusion on our side. So let's just erase the solution and move on to the next question. S dash. And there's a point on the hyperbola that is our origin, right? So we know that S dash is equals to 2AE, and the difference this is equals to 2A. So two informations we have, and we have to find the eccentricity, right? So first let's calculate SS dash. SS dash basically is 24 minus 5 is 19, and 19's whole square is 136, right? 19's whole square is 136. Sorry, what am I saying? 361 is 361, and then plus we have 12 minus 7 is 5, so 25, and then we have a root. So 6, and we know it's not a perfect square, but we leave it to this, and this is equals to 2AE, right? And now calculating the difference. So what do we have here is root of 114 plus 25 minus root of 24 whole square plus 7 whole square. So we are aware that this would be greater. So let's take a modulus. And what do we get? 24 whole square is? So it is, I'm using a calculator, guys. I'm really sorry. My calculating skills have been really bad these days. So what are we left with is, it is 576 plus 49, and that is 5 to 6 per root minus root of 169, and we know what the answer is. 25 minus 13, this gives me 12. So we know 2a is 12, so we get a is as 6, and then we just take the ratio. So root of this divided by, this is 2ae divided by 2a, and that is equal to 12. This is my answer. As simple as that. Okay, you got the equation. Now we're just applying the basic definition of a hyperbola, that we define the hyperbola in this way as well. That the locus of a curve or of a point whose distance from two fixed point, the difference of the distance of from two fixed point is a constant, right? The two fixed points are here the foci. Now moving on to the next question. Next question we have here is the question number 7, and let's see what the question says. The equation of a tangent to the hyperbola, which makes an angle pi by 4 with the transverse axis. Okay, so since it is looking like a standard hyperbola, so let us convert into this into a standard hyperbola first. So let me see. So do we have a 16 factor here? Yeah, we have. So let's let's try to make it happen. X square minus 6x, right? Is it 6x? Yes, it is 6x. So plus 9 minus 9. Then we have minus of 25 common. So we have y square. We have minus of 4y. Then I have to take plus 4 in common. Minus 4. And let this be equal to this. Okay. And now what do we have here? We have 16 of x minus 3 whole square minus 16 into 9 minus 25. Okay, there's a double bracket. We do not need the double bracket here, guys. It just looks messy, so let's not go there. Y minus 2 whole square. And then I have a minus, and minus minus would get plus. So I have 100 here is equals to this. So let's get more uh, clear with the equation. So we have this minus 100 and plus 144. So this is basically 400. So what are we left with is x. So this is our equation, right? I'll just erase the rest of the part and rewrite the equation for better solution. So this is my standard equation. Okay. And now what was I asked? I forgot the question. What was it the question asking me? So I wanted the transverse axis, right? So the conjugate axis is the vertical axis, transverse axis is the horizontal axis. So my axes are 3 comma 2. This is my new axis and this is my parabola, and pi by 4 I have to make this I have to make. This is the tangent. So basically the tangent could pass from this is the tangent and has an angle of pi by 4 basically. So it's making a pi by 4 from the transverse axis. So it would make a pi by 4 with the horizontal axis and the y-axis as well. So we know the slope is 1. So it's very easy to find out. Let us see. So what we can do here is, I would have like went the direct way also. I didn't need so much only. But okay, just give me a minute. Okay, so let us see with the solution that they're doing here is, they did the same thing, they calculated and converted them into the standard hyperbola. And then what they did was this. So we know that for the tangent, the equation is y is equals to mx plus minus, we have a square m square minus b square. This is the standard equation of the tangent. And if we directly put values, we will get the answer. And then we can change the values of x and y. If we take the capital X is equals to x minus 3 and capital Y is equals to y minus 2 and then solve, so we get our answer very quickly. So without any wasting time, let's move to the next part. Let me erase this. Sorry for this. Okay, back to the full screen. And what do we have here? We have already done the seventh question. Now let me take it through. I don't have a pen right now. Okay, this is the pen. Let me erase the all the rough that I've done. Okay, this was a big rough. Okay, so now we are on the eighth question. The eighth question says, if the normal at P to the rectangular hyperbola meets the axis of X and Y at G, capital G and small g respectively, and C is the center of the hyperbola, then prove this. Okay, so let's go. This is what we have. This is our hyperbola, and there is a normal at P, right, that meets the axis of X and Y. So basically, this is the tangent, and this is the normal. So the normal cuts the X and Y axis. X at that capital G, this is my P, and this at small g. And C is the center of the hyperbola. So I have to find GG is equals to 2PC. Okay, what we can do here is first find out the normal's equation. So normal's equation would be, my A is 2 here. So first, let me just write the conventional formula for normal because I've really forgotten. X1 plus y1 is equals to 4. So my slope becomes y is equals to minus x1 plus 4. No, sorry. So it becomes x1 minus 4 by y1 is equals to y. So my slope becomes x1 by y1. So my normal slope would be minus y1 by x1. And the equation would be y minus y1 is equals to minus y by x1, x minus x1. So this is what it is. So I know the slope and I know the points, right? So I don't think I need much more than that. Okay. So I think that clears that up. So this is what my normal looks like. And after calculating the normal, now I have to get where they intersect at x and y. So at x-axis, they intersect at x-axis, I have to find out basically. So my y is 0. So if my y is 0, then my x becomes y1 is equals to minus y1 is equals okay, let me just try to scratch and then I'll solve for you. I cannot just solve it in my mind and give the answer for you. That would be unfair to you guys, not towards me. So minus and this gets cancelled, this and this gets cancelled. So x1, 2 times of x1 is what I'm getting as my x. So 2 times of x1 comma 0. And now putting x as the 0 part. X is 0, so y minus y1 is equals to minus of plus of y1. So y becomes 2 of y1. So this is 2 of y1, 0 comma 2 of y1. So distance what I have is 2 times of root of x1 whole square plus y1 whole square. Okay, so very interesting derivation that we get now. Yeah, this is what we get. Just needed to solve and prove it, nothing out of the box. But it's such a nice concept, right? That you can really use sometime when you solve the questions. if there is something, there is a normal given and it's talking about intersection with the x and y axis, then solving it would be really easy. Okay, the next question that we have, the normal to the curve meets the x-axis at G. It is very similar to the question that we just did, but let's continue and see what the question is trying to say. So this is our hyperbola. The distance from G from of G from the origin is twice the epsilon. Then the curve is, yeah, very similar to the previous question. We just did that, right? We just calculated that it would be 2 times of x1. I really don't need to go over the same question again. I don't know why they're repeating the same question so much. Like it's evidently true what we're trying to prove here. So getting back to the next question we have, find the center, eccentricity, foci, directrix of the hyperbola. Very easy question. I'll not get into it. You just have to convert this into a standard hyperbola and get out the shift the origin, because it is a standard hyperbola without a slant as well. So I will not get into the nitty-gritty of it. So let's move on to the next topic, or the next question rather. So what do we have here? S is the focus of the hyperbola. M is the foot of the perpendicular drawn from S. Okay, let me just on the tangent to the hyperbola. So what they're trying to do is, this is my this, and M is the foot of perpendicular. This is my S on a tangent. So basically, let's take this is the tangent, and this is my perpendicular from the S, and this is my M. Prove that locus of M is equals to a circle. Okay, so let's solve it. We know what the tangent of a hyperbola looks like. So basically locus of h comma m, right? So let them be h comma m here. No, what I have to find the, I don't know, let's see. So the tangent, we know the tangent equation is x1 by a square minus y 1 by b square is equals to 1. This is what my tangent looks like. And the perpendicular, the foot of perpendicular from the focus. So the focus, so the slope here is, really it gets boring after point solving JEE math. Because you might solve it because it's too much solving in parabolas, I must tell you. But then too, it's a part of your job, so let's not get disheartened and work forward. See my motivation, I'm motivating you guys now. So b square by a square, x1 by y1 minus b square by y1 is equals to my y. So there's an x here as well. And the slope becomes b square x1 by a square y1. And my different slope would be, see, there was a formula for calculating the foot of perpendicular easily, but I really don't remember that formula, so my bad. But there was something really easy to calculate it, but I don't remember it. Sorry, guys. So this is my slope of the perpendicular from the focus, and it is passing from a comma 0. So I get two equations, I solve it, and then I get the locus. I'll just move on to from the next question because it's too much calculation, guys. And unnecessary calculation that too. Let's move to the next question. And this is the auxiliary circle, right? We know what auxiliary circle is. The tangents from the foci, sorry, the perpendicular, the foot of perpendicular from the foci basically is the auxiliary circle. So the next part is PQ is the chord joining the points theta 1 and theta 2 on the hyperbola. And we know the difference between their angles is 2 alpha, where alpha is a constant. Prove that the PQ touches the hyperbola this. Why are there so many prove that questions? I don't know. I'm getting bored of this. But okay, fine. Let's go. Let's study. It's important. Hyperbola is a very important topic for JEE Advanced also, because there are a lot of questions that directly come from hyperbola and ellipse. Conics, they love the paper making machine, the IITs, right? Okay. So what do we have? Let's move on to some easier question or some conceptual questions. And this time I'll try to read through the solution because writing them is quite lengthy and it's about irritating after a point. So I hope I can just redo the question. If something comes up to be written, I'll write it through. So what do we have? This is the question what demanded, right? This second question. So let's go to the solution. So the equation of the chord we know passing from points theta 1 and theta 2 is represented by this. I highlighted I highlighted that time as well when we were discussing the formulas for hyperbola. It is a very important equation. So this is the equation of the chord. And what I want is PQ touches the hyperbola. So PQ is the chord joining 2 points. Okay, okay. So basically we got our value of PQ. Okay. So if we got the values of PQ, so what I want is now that it is a tangent to a different hyperbola itself. So let us see what the hyperbola looks like. So this is the tangent. So we know the equation. This is the equation we know. So this is what we get. And it's true. Nothing, it's very direct to prove. Nothing, no logic. You have to just simply solve and get the values. So I would suggest you to do the same. Moving to the next part. We have show that the portion of the tangent to the hyperbola intercepted between the asymptotes is bisected by the point of contact. Okay. So this is what they wanted to know. So okay, it's very easy to solve this as well. What we do here is basically, we know what asymptotes look like, right? For the parabola, it is x is equals to minus b square by a by it is something like this, right? The asymptotes b by a. Sorry, it's not square, it's root of this. So it is x. Sorry, my bad. Yeah, it is y is equals to plus minus b by ax. This is what we have. I saw it just right now, but I was aware it was some of this kind itself. So this is what the asymptotes look like. And now solving the equation, we know the tangent also and the equation of the asymptotes also. So when we know the intersections of both of these points, so we get the value of Q and R. And then we know what the point of intersection becomes. Let's move to a different question. Okay. So we have to prove that if a rectangular hyperbola circumscribes a triangle, it also passes through its orthocenter. So what they're trying to say is there is a rectangular hyperbola, and if it circumscribes 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 a rectangle, so it also passes through the orthocenter. So the orthocenter can also lie outside the rectangle, right? So outside the triangle. So it would pass through their orthocenter as well. So the easier way and the best way to solve this question is through the way of normals, right? So let us see what the solution is saying. We know what the standard rectangular hyperbola looks like. It is xy is equals to c squared, and we know the standard parameter that we take for a rectangular hyperbola is ct comma c by t. Okay. So the equation of the altitude through q. Okay, let us see what they're trying to do. So I'll read it to you for you guys. So the equation of QR, we know what the equation of QR turns out to be. Then the equation of the altitude through P and perpendicular to QR is this. How do we come up with that? We take the slope reciprocal for QR, like opposite by mean is the reciprocal, the negative reciprocal of the slope of QR to get the perpendicular slope, and it is passing through P. So we got the equation there, right? And similarly, the equation of the altitude through Q and perpendicular to RP, and the intersection point is basically around the orthocenter. And this equation is also being satisfied by the parameters that we have. So we know that it would pass through the hyperbola also. Now moving to the next part, we have find the equation of the hyperbola whose eccentricity is pi by 4 and whose focus is a comma 0 and directrix is this. Also find the coordinates of the center and the equation of the other directrix. Okay. So I know eccentricity basically. I have eccentricity, so I have the relation between A and B. So my eccentricity is pi by 4, so it's 24 by 16 is equals to 1 plus b square by a square. And I know b square by a square becomes 9 by 16. B by a becomes 3 by 4. This is what the relation we have. Plus minus we'll take. And for the future we have, for the future references we have a relation, right? So b square by a square we have is 9 by 16. This is the one relation we have. And after that, we have that the focus is equals to a comma 0. So let's take it as capital A to avoid any confusion, because here our A is the standard A that we have for a directrix or a hyperbola. So our focus is basically capital A comma 0, and the directrix is 4x minus 3y is equals to A. So we know that the distance between the directrix and the focus is what is it? It is E square times, right? So see, again, I'm taking inspiration from the solution itself. So the solution is taking the thing is that they're taking the focus as the fixed point and directrix as the line from which they have to calculate the perpendicular distance, right? So basically, what the we know what hyperbola is. Perpendicular distance from the directrix is upon the distance. Sorry, the distance from the fixed point. The distance from the fixed point, that is the focus in our case, divided by the perpendicular distance from the line is equals to centricity. And we take the inspiration from that itself and we got our equation. Okay. So then again, we do changes there, here and there, and get the value. Basically, we're just applying that. I'll not get into the nitty-gritties of the calculator part. We'll just stop there. Let me just check the time if we have one more time for the question. Okay, yes, we have ample of time for another question. So let's see. The next question that we have is find the center, centricity, focus, directive. Okay, whose equation is this? So it's a very basic question. I don't think I'll have to get into the depth of it. Basic question. 1 comma 2 is the origin, and the new origin becomes this. This is the hyperbola that we get. This is the hyperbola that we get. And now to get the values of the center, centricity, focus is very easy. We just take it as capital X. No, as capital X square minus capital Y square is equals to 6. So eccentricity basically becomes root 2, because A is equals to B here. So we know the value of eccentricity already. Now we solve further. Achha, there is a 2 here, guys. My bad, there was a 2 here. So eccentricity is not equals to root 2. We can check the eccentricity later on as well. It's a very direct question. I'm leaving it for you guys to solve. We can discuss any conceptual questions if you like. So let's see this one. This is nice. Prove that the angle subtended by any chord of the rectangular hyperbola to the center is the supplement of the angle between the tangents to the ends of the chord. Okay, so the diagram that we have here that has been shown in the question as well. The angle, this is let this so let this be the rectangular hyperbola, and the angle subtended by any chord. So this let this be a chord at the center. So this is our center, right? Let me just erase it again. And by the tangents. So if this is the tangent, so what is it? Is the supplement is basically the difference is 180. If this is theta, this is 180 minus theta. So how can we solve this? Let's take any random chord equation. That is, we know what the equation of a chord looks like, right? We just simply take a point, see these 2 points, and write the equation of the chord, and then calculate the tan theta angle. You get it? See, first of all, let's do it. Chalo. T1 and T2. So here it would be CT1 and CT2. Sorry, what am I writing? Sorry, just give me a minute. Okay. So it would be CT1 comma C by T1, and this would be CT2 comma C by T2. These are 2 points, and the slope of this would be slope would be equals to C is basically 1 year, right? No, God, just let me erase it and start again. Let's go with the solution, guys. I'm really sorry for the confusion in my mind. So let's take a standard rectangular parabola, a hyperbola. And why we have taken this? Because it's very easy to solve with this equation. So now we know what the slope of OP and OQ is. Because basically OQ and OP are points on the hyperbola, and let them be x1, y1 and x2, y2. So we know the slopes of those. So we can calculate the angle between those two slopes. That is equal to this formula that we are using. And now to calculate PIQ, what we do is we calculate the equations of the tangents and get out the slopes. So the slopes are x1 by y1 and x2 by y1. Oh, sorry, x2 by y2. So these are the two slopes. And when we have the slopes of these two tangents, so calculating the angle between them is very easy. So we know we have two angles, tan theta and tan phi. And to calculate if they're supplementary or not, we just can see that tan theta is equals to minus of tan phi, which is also equal to tan of pi minus phi. And that directly gives me theta is equals to pi minus phi, and that becomes supplementary. So I think we can stop here. Let me see the time again. Do we have more time? We do have time for one more question, so let's go. The chord of the ellipse is this, touches the hyperbola. Okay, so let's draw. This is what we have, and this is this. So the chord touches the hyperbola, but how can it touch it? Okay, so this might be the chord, and one extending it, it might touch the hyperbola. So that the locus of the midpoint is this. So very time applying the equation. So this was like a really important question for our in my JEE days preparation as well. So this was what the question, how we solve the questions. So I hope I can stop with the questions here, and I hope I see you in the future classes. Okay, bye.